purpose of this lesson is to learn about declaring and using variables, learning about data types, how to use arithmetic operations, how to perform data conversions, how to use constants and enumerations, and then also how to accept console input. We are going to start using locations in memory that we need to give names to, and these locations in memory will contain things like numbers, they'll have values, they'll have strings, and we call these variables and constants. A variable is a named location that I can change the value at any given point in time when the program is running. A constant is kind of like a variable, except a constant will be assigned a value when the program is actually first run, and that location cannot change. So if I want to have a value for our sales tax rate, well, the sales tax rate is not going to change during the time that our program is running, so I will actually put that into the program as a constant. A variable would be something like if I'm making a program that is trying to calculate the total price for a sale, the variable is going to be what was the price of the item, and it could change from one item to the next. My sales tax rate, I don't want it to change, so I make it a constant. It stays the same throughout my entire program. A variable can change. There's also another thing called a literal or a literal constant, and this is going to be something that is just taken at face value. So if I actually put the number 25, or if I output something on the screen like hello world, that is a literal. So whatever I typed literally is what is being displayed on the screen. It's not coming from a variable. Whenever we play with variables, we have to worry about the data types. And we have several data types that we can play with. Our basic ones are going to be bytes, shorts. Of these that are listed here, the ones that you will typically end up using are going to be bytes, integers, long for a long integer value. And if you notice, the difference between any of these is how much the smallest and largest value can be. We have floats, doubles, decimals, characters, booleans, and strings and objects. These are the ones that we will use most throughout this semester. Whenever we want to use a variable in C#, we have to declare it first. Some languages don't require you to declare it first. In C#, you have to make that declaration. The actual process of creating a variable is actually called dimensioning. So I'm going to dimension some space. I'm going to allocate a place in memory that is to be used for holding the value for this variable. So what I can do is I can declare multiple variables at the same time. So typically what we'll have is at the top of our program, we will have a block of declarations. So I will declare all of the variables that I'm going to be using in a particular method all in one spot, and we just simply put them one per line. Now there's a shortcut that if I'm declaring a bunch of integer values, or I'm declaring a bunch of floats, or a bunch of doubles, or a bunch of strings, I can actually declare them all on the same line and just simply separate them by a comma. It's a shortcut, so I'll show you both of those later in this lesson. So a declaration just looks like this. We start off with stating the data type, so in this case it's a double. We give it a name, some money, and if we want, we can provide an initial value for it. If I simply were to say double some money and then put my semicolon and not include this part of it, it would still declare the variable location, but the location actually wouldn't have a value in it, therefore it would be a null value. That's typically fine as long as I provide a value to that memory location before I actually try to use it. So let's say in this example, what we're doing is we are going to create a double value. We're going to call it some money, and we set it to $39.45. Then we're going to write a line of text out to the console, and what's going to be written is whatever's in that variable location. Alright, so that's fine, but if I didn't declare that some money is $39.45, then what would happen when I try to run this next line of code is I would actually crash the whole program. So make sure that if you're going to declare it and immediately use it, that you give it an initial value. If you know for a fact that you're going to get input from the user, or that you don't necessarily need the value before you actually use that variable, then you can leave that off. My recommendation for the time being is to give all of your variables an initial value. So in the case of this example, what would happen is we simply run the program. It displays the value the value that is in that memory location, and that's all that this does because it was just simply a write line command. In this next one, we're going to add a little bit of text to it. Alright, so what I want to do is I want to declare that value of some money to be $39.45, and we're going to issue a console.write. So we're going to write a line of code, but we're not going to issue a return, which means it will put the money is and then the $sign on the line, and then it doesn't issue a carriage return. Therefore, anything that comes next would be displayed to the right of this. So on the next line, we have console.write line, some money, and what would actually happen is it will display the whole thing on one line. So the part where it says the money is $sign comes from the first line of code. The $39.45 comes from the second line of code. There are a couple of ways we can do this. We can concatenate it, so we can actually put two text strings side by side. We can display things out to the screen like this. Or we actually have other ways that we can do this will be a little bit easier. So what I can do is I can format my strings of characters. I can specify that it has to be a fixed text, that it has to have a certain width. I could specify that whatever's coming is going to be money and should have a $sign. I can also specify where it's to be located on the screen. Now my options are limited with a console application. All I can do is indent it so many spaces from the left, and then I can specify if it's right aligned or left aligned. We'll get to that in just a minute. Alright, so what I'm going to do is I want to shorten that prior example. So in that prior example, we did the console.write, the money is, and put a $sign, and then we did a console.write line and then put the value after that. I'd rather do this as one line of code. So to do it as one line of code, what we're actually going to do is we're going to use what's called a placeholder. So we're going to start off with console.write line. The money is $sign, and if you notice here we have a set of curly brackets that contains the number 0. Remember, when we talk about a list of items, the number 0 is actually our first item in the list. You need to remember that. So our first item is 0, our second item is 1, our third item is 2, and so forth. So what we can do is, in this example, it says the money is $0 exactly, and then down here we have a comma, and then some money. And if you notice, our literal portion of it is in quotes, which means it tells the system, hey, this is text, comma, and then this is a variable location that we're trying to reference. So we want to read in whatever's here. And the way that this will work is it will take whatever value is here and substitute it where this placeholder is. So when you run this one, you get something like this that says the money is $39.45 exactly. So the $39.45 is where the placeholder was. It read the value in from some money, and then it put it into this location in the place of the placeholder. We can also format our output. So I want to write a line of code that is 5 characters wide, and we're going to put the number 4 in it. And what we can do is we can actually specify where it starts, how many characters wide it is, and then what value is supposed to be written here. So our placeholders will look like this. What we're going to do is this is our placeholder 0, and it's looking at value number 0. Okay, so like in our prior example, this is placeholder 0 is looking for value number 0. Okay, so for this one, placeholder 0, looking for value number 0, which value number 0 is actually the number 4. Okay, so this represents whatever is over here. The 0 represents this 4. The 5 represents that this is actually supposed to be 5, it will take up 5 character spaces on the screen, and it will actually right align it. So what I end up with is on this next line here, value 0, which is 56, should take up 5 character spaces on the screen, and it should be right aligned. It's a positive value, means right aligned. If you think about a number line, it makes it easier to figure out what your right align and left align are. On a number line, a positive value is to the right, a negative value is to the left. Okay, so what happens is if I format one like this, item number 0, which is Richard, gets substituted in here. It's going to tie up 8 spaces on the screen, but since it's a negative, it will be left aligned. Item number 1, which is actually the second item in our list, it will be substituted right here. It also will take up 8 spaces, and it will be left aligned. All right, so let's look at Marcia. Item number 0 is Marcia. Marcia's name will take up 8 spaces, and it will be left aligned as negative. Parker will go in for number 1. It will take up 8 spaces and is also left aligned. So what this will look like is this, where the number 4 takes up 5 spaces. It's right aligned. Remember, it was a positive 5. 56 is also taking up 5 spaces, so the system will automatically insert blanks for the extra spaces, and what this will do is let us be able to format things so that they are lined up nice and neat, such as the example down here. Left aligned, remember these were the negatives, they take up 8 spaces, so I have 1, 2, 3, 4, 5, 6, 7, 8 spaces, because we're including this space here. So Richard takes up 8 spaces, and it was a negative 8, so it's left aligned, which means that it gets put over on the left side of that 8 spaces. And then the word Lee also takes up 8 spaces, so there's actually blanks out here that you can't see, and Lee gets left aligned because it was a negative 8. The other thing that we can do is, just like in most programming languages, I can concatenate strings. Now, what happens is, if I have a text string and I were to put a plus sign in the middle, the plus in this case does not mean addition. If this first item here is a text string, then what it will do is it'll treat this plus sign as a concatenation, which concatenation just simply means to put 2 text strings side by side. So what I will end up with is the word concatenated with a space and then string, and the 2 of those put together. Now this is going to be used rarely. We're going to use the placeholders a lot more frequently because they're a lot more friendly. It's a lot easier to try to troubleshoot, and I want you to get out of the habit of using the plus sign concatenation unless you absolutely have to use it. Alright, so we have integral data types. Now these are whole numbers, so what you actually hear me reference these as is integer data types. Integer and integral are actually interchangeable terms. However, for those of you that have ever taken a calculus class, you will know that an integer is a whole number and an integral is a specific function in calculus. Therefore, for the purpose of this class, I will call these whole numbers integers. Alright, so I have different types that will hold whole numbers. I have bytes, S bytes, shorts, U short, int, and so forth. The one that you will typically see me using is going to be an int, the int. And the int holds a whole number. It's just simply a data type. And then we have shorter ones, and the difference is going to be how much memory do these actually take up. Remember, everything that we're creating as a variable is a named memory space, therefore it will take up space in memory. So if I allocate space for a 256 byte value, then I'm actually tying up 256 bytes worth of memory. Doesn't sound like a whole lot, but if my program has a lot of variables in it, there's a possibility that my program will eventually use more and more memory because I'm adding more and more variables. We also have what are called floating point numbers. We reference these as decimal point numbers. So if I have something like 3.2, that is a decimal number. In our programming language, those are going to be floating point. Now, our simplest version of a floating point is just simply called a float. It can hold up to 7 significant digits of accuracy. Okay, now, what that means is that my entire number, including everything in the integer part, dot everything in the decimal point, can only be 7 characters in length. So if I have 1, 2, 3, 4, dot 5, 6, 7, that's as big as that value can be. So typically what you'll see me use is going to be a double, because a double can hold up to 15 digits. And then we also have what are called decimals, which a decimal is going to be a smaller range of values. Typically it's going to be something that has 2 decimal places. Alright, so the question is, what is a significant digit? A significant digit is just simply however many decimal places that your number actually has and how accurate it is. Alright, so if I can only have a value that has 7 significant places, then that means at most I can only do 0.1, 2, 3, 4, 5, 6, 7 places. I can't have anything beyond that. So if I'm trying to take some value, say for example pi, which pi is 3.14, and then an infinite number of non-repeating numbers. Alright, so if I'm using the number pi, I need the number pi to be as accurate as possible. And if I try to estimate pi as 3.14, as I'm sure you've experienced in math classes, then pi will actually cause my actual answer to be off just a little bit. Now, pi as 3.14, that's a fairly accurate approximation, but if I'm doing something that is requiring accuracy, so if I'm trying to machine a circle, or if I'm trying to project a flight for a rocket or something like that, I need accuracy. I can't use approximate. Be aware that a float and double, because they have such small amount of significant digits, those are actually going to be approximate values. Where you will see this is when we start doing things like calculating sales tax, or if we start calculating interest rates or things like that, we'll notice that sometimes the actual amount that is owed may be off by a penny. And that will happen because those values are not necessarily accurate. They're approximate. Alright, so what I want to do is sometimes I have a number and I need to treat it like a float. And sometimes I have a number and I need to treat it like a double. And I have a number that I need to treat like a decimal. So what we're going to do is we're actually just simply going to put a capital letter F after any number that represents a float. And I'm going to put a capital letter D after any number that represents a double. And I'm going to put a capital M after a number that is a decimal. So the question is, why an M? Well, two answers. One is D is reserved for something else. And typically we use decimal places for money. So M would be a good representation for money. Scientific notation, we use the letter E. If you've ever dealt with scientific notation, it's always 10 to the power of something. So on a calculator you see something like 10e and then however many, whatever the exponent value is. So we typically represent the scientific notation by E. C# will display the floating point value numbers in the most concise way that it can. So what will happen is when we try to get a value that has a really long decimal place value, it'll actually truncate that value. Now, it will try to keep it as much as it can, but if we use a float and we perform a calculation on a float that has a very long decimal place, and then we perform another calculation on it, each time we perform a calculation on that float, it will become more and more inaccurate. So just be aware of that. If we're playing with floats, a float is not accurate, and the more times I perform a calculation on it, the less accurate it gets. Alright, so these are our format specifiers. What you'll see is just simply that we take the numbers, and what I'm going to do is for currency, I can convert something to currency by simply designating that that's what it's going to be formatted as. The system will automatically put a $ in front of the value. It'll automatically put a comma for the placeholders for the thousands place, and all I have to do is just simply specify. So if I were to tell it, write the number 10000 to the screen, hopefully I had 4 zeros there, but it should be 10,000. It'll automatically put a $10, 10,000. Then that way it'll format it as money even though I didn't actually specify that it was money. Binary operators, these are going to be your operands. Okay, now an operand is just simply all of the different arithmetic functions that you can do on numbers. So I can do things like multiplication, division, addition, subtraction, and another one called modulus. And a modulus, if you think back to elementary school, you used to use these, you just didn't realize it. When you did a division problem back in elementary school, if I took 10 divided by 3, what you would do in elementary school is you would write 3 and then R1 for remainder 1. Well, that remainder of 1 is the modulus. So the modulus is just simply what is the remainder when you divide two numbers. So if I take 10 divided by 3, I'd end up with something like 3.3, and then the 3 would just be repeating forever. If I were to do 10 modulus 3, my answer would be 1, because that's the remainder. So when we play with the modulus, it's just simply what is the leftover, what's the remainder when I divide two numbers. our operations are the addition, subtraction, multiplication is the ampersand, division is the forward slash. Make sure you notice the one on the key with a question mark. And then your modulus is a percent sign. So if I wanted to actually type out 10 modulus 3, I would put 10% sign 3, and then that would calculate it. So in this case, it says 45 modulus 2. So 45 divided by 2 is 22 with a remainder of 1, so our answer is just 1. Be aware that our calculations are performed left to right. They will always be performed in our order of operations. So multiplication and division will be performed first, then our modulus, then any exponents if we have any, which we'll use later in the semester, and then our addition and subtraction. If you think back to math class, there was an acronym, it was PEMDAS, or Please Excuse My Dear Aunt Sally, that is actually followed. So if I did something like 3 plus 2 minus 4, it's going to perform that in order. But if I do 3 plus 2 times 4, it'll do the 2 times 4 first and then add that to 3. Alright, so what I can do is I want to perform some calculations on numbers. I want to keep increasing numbers. And in other programming languages, if I want to add a value to itself, let's say I have a number and I want to add whatever's currently in my number to 1, I would do something like my number equals my number plus 1. Well, in C# we actually have some shortcuts that we can use. Alright, so in this case here we have a bank balance, and whatever's currently in the bank balance, which is over here, we're going to take whatever's currently in bank balance, we're going to calculate whatever the bank balance is times the interest rate, and then we're going to add it back into bank balance over here. So what happens is we're going to take the existing value, add it to the calculation over here, and then stick it back into this value. Whenever we're dealing with arithmetic calculations, we are always going to be manipulating the value of whatever the variable is on the left side. So what we're going to do is we're going to evaluate this side and manipulate this side. Alright, so we can do a plus equals, and that's the same thing as bank balance equals bank balance plus bank balance times interest rate. We can also do what's called a prefix incrementer, and we can do a postfix incrementer. And we actually can do this with addition and subtraction. Let's say I want to increment a number by 1, especially like when I have a counter. If I'm counting up from 1 to 10, in other programming languages, you'd have to say something like x equals x plus 1, and then every time you go around, then x gets incremented by 1, and you add 1 to it, and you keep doing that. Well, in C#, I can actually do that as a shortcut. What I can do is I can tell it, well, instead of saying x equals x plus 1, I could just simply say plus plus x. And that's the exact same thing as saying x equals x plus 1. Alright, so the difference here between a prefix and a postfix. Alright, try not to use a postfix. If it's counter, no problem. If it's something that we're actually trying to count a value and we're trying to store it, then we want to do the prefix. Alright, so the prefix, what it will do is if I were to increment some value, let's say right now some value is 3. If I do plus plus some value, what it will do is it will add 1 to whatever's in some value. It was 3, adds 1 to it, now it's 4, now it will perform the next calculation. The postfix increment, what this one will do is it'll provide this value to whatever the output is, and then it adds 1 to it. So let's say I wanted to print out the value of some value. Alright, if I do the plus plus some value, plus plus some value was 3 to begin with, now I want to see what the answer is afterwards. Okay, so what it would do is it'll say, alright, it was 3, add 1 to it, your answer is 4. The postfix, what it will do, it was originally 3, it will tell me that it's 3, and then it adds 1 to it. So even though I asked it to add 1 to it, it doesn't add it until after it tells me what that value is. So be aware that there is a difference in the way that they work. So do I want it to present the value to me and then add 1 to it, or do I want it to add 1 to it and then present the value to me? We have these things called unary operators. That's something like if we have a negative number or a positive number. That's our unary operator. So we're going to make it either positive or negative. Then we have a decrement operator, which is meaning to subtract. So we can increment something, we add to it. We decrement, which means to subtract from it. Please note that there's a difference. If you use one minus sign, it means make it negative. If you use two minus signs, then it makes it a subtraction problem. We also have Boolean variables. These are going to be things that are true or false. Those are the only possible situation that they have. There's no maybe or three or anything like that. So if I have two items and I want to compare if they're true or false. Let's say I want to say if 3 equals 3, then do something. 3 will equal to 3, so it'll be true, therefore it will do it. So our Boolean expression is going to be either true or false, and depending on what the outcome of that is, we'll decide if that statement gets run or not. Alright, so whenever I run that, I have these operators that I can play with. I have a less than sign, greater than. Please be aware that the rest of them that involve an equal sign require two characters. If I want to compare two things, I have to put two equal signs. If I only put one equal sign, that's an assignment operator and means to replace whatever's the value on the left with whatever's on the right. I don't want to do that. If I want to compare two numbers, I have to have two equal signs. Alright, is it less than or equal to, greater than or equal to, or not equal to? So I want to see if 3 is not equal to 3, then do this. So a Boolean expression, the way that this works is a little bit different. In our other data types, what I'm going to do is I'm going to figure out what the calculation is over here, and then I will put that answer into my variable location. So in this case, we're creating a variable that is of a bool data type. Its name is employee worked overtime, and remember, employee worked overtime can only be true or false because it's a Boolean value. Alright, so what we're going to look at is, let's pretend we had a variable somewhere up in our program called hours worked. The system will look at the number of hours that they worked and compare it to 40. So if the number of hours worked is greater than 40, then it will put true into employee worked overtime. If the number of hours worked is less than 40, then it will put a false into employee worked overtime. Then after we know that this is true or false, then we could say if employee worked overtime. Alright, now honestly, it's actually a little bit easier to do it a different way, and I'll show you in a few minutes when I actually make a program. But what I can do is I'm going to specify bool employee worked overtime, and typically I'll say that equals to false, just because I need to give it some sort of initial value. And then this hours greater than 40, I will put here. So what I want to do is just simply say if the hours that they worked is greater than 40, then do this code. Alright, now that may not always be the best way to do it because sometimes I'm going to have to use the same calculation or use the same value over and over again. But if it's just like a one-time thing, then I'm going to put the actual calculation here. Alright, so we're going to start running into some problems where you will have to do comparison operators, or you will have to try to concatenate or to do other type of functions using different data types. And you actually cannot do two things with two different data types. So what I need to do is somehow get the system to allow me to do that. Alright, so what happens is C# will actually use what's called a unifying data type. And so what happens is the system will actually try to figure out between two values, if I have, say, a float and a double, then it will convert the float to a double automatically. It does it implicitly. And then it will try to do my comparison using both of them as a double. There is a chart in the textbook that will walk you through what the order is and actually how they get converted. But you need to be aware that there are some times that you will not be able to do the implicit conversion. Sometimes we will have to actually explicitly tell the system, hey, I'm going to give you a number, and I want you to treat it like an integer, and then let me do the calculation or the comparison. So it doesn't always allow me to just simply stick two numbers and say compare them. Alright, so the implicit cast is going to be that I'm going to let the system just automatically take whatever's in a value and put it in another one. So for example, here we have an integer, and it's a variable type called an int. And then we're going to stick whatever its value is into a double. Well, we can't really do that. So what happens is if I take the number 4 and try to stick that into a double, it has to automatically convert my integer 4 to 4.0. And so there is actually a converter built into C# that will automatically do this for us, and it just simply takes and converts it. The problem is if I go the other way. So if I try to take a number that is a double, let's say I take the number 3.2, and I try to stick 3.2 into an integer value, that won't work, because what it will do is it will actually take the 3.2, get rid of the 0.2, and try to stick it in the integer, and it knows that's not allowed, so it won't let you do it. So if I want to force it to do it, then what I'm going to do is I'm going to say, hey, this thing's a double, and even though it's a double and it's 3.2, I want you to treat it like an integer. Now what it will do is it will explicitly cast this thing and treat it as if it were an integer. So before it even does anything with this, it converts it to just a whole number. So if this is 3.2 right now, we tell it, hey, treat it like an integer. It says, oh, hey, okay, I'm going to treat this like 3. Then it will take 3 and put it into my integer value. So if I'm going in the order of the implicit conversion, if it's possible for the two data types to be put together, the system will do it on its own. If it's not possible, then we have to explicitly do it to tell the system that it's allowed. Alright, so we have some other data types. We have a character data type, which is just called a char. And this holds a single Unicode character. It will just be one letter, or one character, or one symbol from the Unicode set. There's not a way to put more than one character into it. So if I designate that a variable is a char data type, it only gets one letter. I can also use things called escape sequences. Now what this does is it allows me to do things like line breaks, I can do carriage returns, I can beep the system if I want to. These all begin with a backslash, and each of these two characters actually represent one particular thing on the screen. Okay, so if I'm in the middle of making a text string, my text string has to be contained in a set of double quotes. Well, if I want to get a double quote to show up in my text string, and I put that in my text string, the system will treat it as if that were the end of my string. So instead of typing in a double quote, I'm going to put a backslash and then a double quote. So what I'm doing is I'm telling it this is an escape sequence. The backslash is our delimiter for an escape sequence. And we're telling it that, okay, whatever I type next, ignore it. You're not going to use it as a command, even though it may look like one. So if I want to have a backslash, well, since the backslash is a delimiter, I have to put 2 backslashes. If I want to have a null value, then I put a backslash 0, because if I were to just simply put the number 0, it would be the number 0. That's not null then. Okay, so I can do new lines, I can do carriage return, I can do tabs. All of this can be done directly from these delimiters. We've been discussing the strings, and a string is just simply a series of characters, and we designate a string by putting it inside of a set of double quotes. Now, the strings, I can actually compare them. And the way that this works is to do a comparison, it will actually convert the letters that are in the string to their ASCII or Unicode binary values. And then it'll compare them at that binary level. So I can actually compare the word hello to the word hello. And if I have hello with a capital H and compare it to hello with a lowercase h, they are not equal to each other. So what we can do is we can start providing things like here we have a name. We have Amy. We're providing the name Amy into name 1 and name 2, and Matthew is name 3. And so what we're trying to see is if those are equal to each other. So we're going to say compare Amy to Amy, because that was name 1 and name 2 here. And then whatever is the third item here will be our output. Okay, so 0 is the placeholder for name 1. 1 is the placeholder for name 2. Oops, sorry. And then 2 is the placeholder for this calculation. So what it will do is it will perform the calculation, it will look at what the values are for these variables, and then it puts them in here. Okay, so name 1 and name 2 are both Amy, they both have a capital A, so they should be true. So what we'll end up with is compare Amy to Amy, true. And then here we're going to compare 0 to 1, which 0 this time is name 1, 1 is name 3. So now we're comparing Amy to Matthew. Alright, so we'll compare those two, see if they're true, which is false, and it will say compare Amy to Matthew, false. We can also do a string dot equals. Now this is a method that's built into C# that lets us do the exact same thing. So if I want to see if name 0 is equal to name, if name 1 is equal to name 2, what I can do is I can say string dot equals and then put inside what these are. So I can say name 1 comma name 2. All that it is a built-in method that will actually perform this comparison for me, and I don't have to actually type it out here. Where this actually excels is actually a little bit faster to do the string dot equals, and it will also do our typecast for us. Alright, so we can also figure out what the length of our string is. So we can look at the string. We have a string called a string, and what we can do with this is our variables have sub-methods that are available to them. So I can have a string dot length. That's a value that is actually assigned to every variable that is created. So what we can do is we can look at this and see how long it is. We can also do what's called a substring, and a substring is going to be look at a particular word, start at so many characters in, and look so many characters in length. So for this word water, it's 5 characters in length. It starts at character 0. So if I start at character 0 and only look at one character, then we're actually looking at just the letter W. If I start at the second character, or character number 2, then we're going to start here and go 3 letters. So then we end up with T-E-R. So the idea here is that we can actually look at a part of this word or the whole word, and we can even look at the length of it to see what the length is. We want to use named constants, and like I said, these are going to be used throughout our program to try to get rid of what's called a magic number. A magic number is going to be something that just shows up out of nowhere. So let's say I'm trying to perform a calculation of sales tax. I have the total is equal to the item price times 1 plus the 0.06. Where did the 0.06 come from? Well, if I were to change that to something more along the lines of total price is equal to item price times 1 plus sales tax rate, now I know what that 0.6 is. And now what this also does for me is if I use the sales tax rate as a named constant, I define it one place in my program, and everywhere else in the program that references the sales tax rate, we just reference it by name. Which means that if my sales tax rate ever changes, I don't have to change it a whole bunch of places in my program. I just change it that one time as the named constant. We have things called enumerations, and an enumeration is nothing more than a list of strings. So I can have a list of strings of the days of the week. I can have a list of strings of our planets, months, anything like that can be in my enumeration. An enumeration is just simply each item gets a value. And so if I were to look at this, the word Sunday is 0, Monday is 1, Tuesday is 2, Wednesday is 3, and so forth. So if I were to look at this and say days of the week, value 0, it would tell me that the answer is Sunday. So if I were to look at the days of the week and I were to look at Monday, it would tell me that the Monday is number 1. We also can make interactive programs, and now this is where we're going to start getting into programs where the users can provide input. We've used the console.readLine method before, and the readLine method we were just simply waiting for the user to press enter. Well, the readLine actually does more than that. It takes whatever is typed on the screen, and when the user presses enter, it will commit it to memory. So what I can do is I can create a variable and set it equal to console.readLine, and then what that does is whatever the user types in gets put into that variable. Now be aware that whatever gets put into this variable is going to be a text string, because that's what the console.readLine is. It's reading in a text string. So I have to be aware that if I want to ask the user to input a number, they're going to type in something that looks like the number 3, but it's actually a text string representing the number 3. And then when I want to perform a calculation on it, I have to convert it to a number first. So what I'm going to end up with is I'm going to set a variable location equal to something where I actually want to read the data in from the console. I'm going to stick it into a string value, and then I'm going to convert that string value to whatever type of number that I need. So there is a function called convert, and the function convert has subroutines that allow me to designate what kind of value I'm going to convert it to. So I can convert it to a string, to an integer, to a decimal, to a double. I can do all of those. But the way that this is going to work is I'm going to create two variables. One for this value as a text string, and then one for the value as whatever the data type is that I actually want it to be. We have all of these available to us. So we have booleans, bytes, characters, all of the different data types we can convert to, and the system will do it automatically. All we have to do is call the convert method, dot whatever conversion type we need, and whatever's in the set of parentheses will automatically get converted. I want to start making programs that allow us to use variables and also ask the user for input. So what I have done is I created a template file. And what I would recommend is you do the same thing. Now my template file just has the contents of using system. I created a namespace, which in the prior lesson I didn't have you do the namespace, but I would suggest getting in the habit of setting it up like this. So we have a namespace, and then the name of the program goes here, and then this left curly bracket, if I click on that, you'll see it, the one down here turns red. So these two belong together. And the way that this works is you'll see the namespace and then the name of the namespace, and there's no semicolon here because this namespace contains all of the stuff that's in between these brackets. If I were to put a semicolon right here, that would be the end of my statement, and that's not. All of this is my statement. Alright, so my namespace contains all of this. Then I have a class which is just simply going to be called program. This is the actual program, part of our program. And then it has an opening curly bracket and a closing curly bracket. Inside of there we have our static void main, which once again these have container objects, so therefore we're not going to have a semicolon. Static void main, this is my main method, so once again no semicolon, and it contains all of this. And my actual code will go into here. So by having a template, what I am doing is I am simply putting up here, and this actually should be whatever the program name is. So I'm going to make my template so that this is the layout for it, so that all I have to do is copy and paste this each time I want to make a new program. So what I am doing is I'm going to take these two items and I'm going to drag them with the right mouse button into the Chapter 2 folder, and when I let go it'll give me the option to copy here. Alright, so now I have them in here. Now this template, I want to actually take this template and make a copy of it. So same thing, I'm going to right drag it, copy here, and then I want to rename this. Alright, so this first program is going to be measurements for a room. We want to figure out how much carpet the room has or something of that nature. So I want to find out how much square footage we have. Alright, so this particular program, we start off with the namespace, which is going to be called room. And our class is program, static void main, so all my code actually goes inside of here. Alright, so before I start, I'm going to do my block comment. So my name, today's date, the class of CIT 147, and then the last thing in here is going to be the program, so or calculate room area. Alright, so that's my block comment at the top. Alright, so what I want to do is I want to calculate the area of the room. So I need to have a length and a width to calculate the area. Alright, so my formula is going to be something like declare a variable for the length, declare a variable for the width, and then declare a variable to hold the area. Alright, so what I want to do is I want to declare these, and I'm going to do it the long way first, and then I'll show you the shorter way. Alright, so I'm going to declare an integer value to hold the length of the room, and I'm just simply going to do this. That's it. So I'm just declaring it. Now what will actually happen is it will create a memory location but the contents of that memory location are actually null. There's nothing defined. And then I'm going to do the same thing for width, and then the same thing for area. Okay, so then what I want to do is I want to provide values for those variables. Okay, so my length, and remember it's always going to be which one do I want to manipulate on the left side, and then the equals sign. Remember, equals is an assignment. So we are going to actually take whatever's on the right side and stick it into the length variable. So I'm going to say that the length for, or the value for the length is 15. The value for the width is 12. And my area is equal to length times width. So now what I have is I have a value of 15 that goes into length, a value of 12 that goes into width, and our area is the length times the width. Alright, so then I can do things like actually figure out what the width or what the area is, and then I can display that to the screen. Okay, so I'm going to say console.WriteLine, and then I want to display just the area. Alright, so this is my basic program for calculating the area. Alright, so I'm going to compile it. So I run my command with path, which opens up in the folder. I want to do csc room.cs, compile it. Okay, now I'm getting a message that it's provided with a .NET, but it only supports various versions up to 5. This actually should be okay. It's just simply because I have Windows 10 on my computer. I'm going to try to run Room, and it should work. If not, then I may have to change my location of the .NET framework in the path. So it works. So ignore this message. That's okay. It just simply means that I'm on a newer version of Windows with a newer version of .NET framework. Okay, so what I've done is I've simply written out to the screen that the area is this, but what does 180 mean? All right, so when we actually design programs, we should be telling the user what that means. All right, so I'm going to move these around so I can easily get to them. All right, so what I want to do is I want to do something like the area of the room is, and then whatever the area is. All right, so I'm going to do it the old way, the concatenation way, and then I will do it the new way. So to put this in, what I'm going to say is the area of the room is space, and then close the double quotes, plus area. All right, so let's compile this. Then we'll run it. And now I get something that says the area of the room is 180. Okay, I wanted to have a period at the end, so I'm going to put a plus sign. I have to put a period inside of the quotes. Okay, let's go compile it again, run it, and now I get something that looks more like a sentence. All right, so the thing is I got to try to figure out where I put the plus signs and the area and everything, so I'm going to show you an easier way to do this. Instead of all of this, I'm simply going to replace it with a curly bracket, 0, and then a closing curly bracket. Alright, so now what that means is that it's going to put this sentence out on the screen, but where this placeholder is, I want to put a comma here, and then we're going to put area over here. So now what this does is it says the area of the room is, and it replaces this 0 with the first thing in my list, which is area. So this will actually give me the same thing, but it's a little bit easier to figure out where I put the placeholder because this actually flows right in with the language instead of trying to figure out all the pluses. Alright, so saved it. I'm going to compile it. We'll run it, and we get the same thing. Because all it did is took the area, replaced it in here where the 0 is, and that's our actual output. Alright, so I want to get rid of these 3 lines. This is kind of redundant. Alright, so what I'm going to do is in my actual declaration, I'm going to give these initial values. So my length is equal to 15, my width is equal to 12, and my area, during the declaration of it, I can actually make the area equal to length times width. So now what I'm doing is I'm getting rid of these 3 lines completely. And now I have 3 lines for declarations, 1 line to write it out on the screen, save it and compile it, run it, and we get the same thing. Alright, I can make it even shorter if I want to. Because what I can do is I can combine these 2 lines together if I want. These are like declarations. So what I can actually do is I can put one right after the other. All right, so I'm going to declare length, comma, and then I'm going to declare width. And width is equal to 12. Okay, so now this line goes away. And now I have this. Now technically I could declare this one up here, but then it gets to look like it's really cluttered. It's easier to figure out when you go through to troubleshoot it if it's like this. So try to only declare them one per line if they're a single value, and then if they're something where it's a calculated value to declare it, then put it on its own separate line. Alright, so I'm going to compile it, run it, and I get the exact same thing. So my 7 lines of code that I had before, I've now gotten down to 3 lines of code. Alright, so I need to comment my lines. Remember, for now you're commenting everything. So this is going to be declare variables. Okay, now your declaration area, what you can actually do is put this declaration above the block where you declare them. And what I would like you to do is have all your declarations, one per line, or however you need to space them out, but make sure you leave a space before the next section of code. That way when I look at this, I can see that this is declaring variables, and all the stuff that's here together is declaring variables. Then down here, we're going to do something like output answer. Just answer. So now this gives me an idea that you're declaring the variables here, and down here you're providing the output for the answer. Save it, compile it again, run it, and I should get the same thing. Alright, so I also want to start including my console.clear and also my console.readline. So that way it clears it, and then it also waits. So that way if I double click on it, then it won't close on me. And so now it clears. It's waiting for some sort of input. I press enter, and then it exits the program. Alright, so this is your basic program for calculating area, and it's actually 3 lines of code is all that it requires to be able to make this entire program. Alright, so this version of the program simply calculates the area. I want to know what the price is for this. So what I'm going to say is that each square foot of carpet is $12.99. Alright, so what I'm going to do is I'm going to come up here and I'm going to declare another variable. Now the thing is though, is that I'm going to declare a value that should not change because the price for this is going to be constant throughout my program. Alright, so what I'm going to do is I'm going to declare a constant, and then this one's going to be a double value, and I'm going to call this cost per, let's say cost per square foot. Okay, so I'm just simply calculating, I'm sorry, I need to give it a value, and this is going to be $12.99. Alright, so our cost per square foot is $12.99. It is a double because it has a decimal place in it, and it is a constant, which means that this value will not change. I'm not going to give it any assignments or anything else like that through the program. We'll try to change this value. Alright, so what I want to do is, this isn't just outputting the answer now, this is outputting the area. And I want another line that will output the cost. Okay, so I'm going to do another console dot writeline. And I'm going to say the cost of the, let's say it's carpet that we're is, and then now I'm going to start with 0 again because this is a new line. There's a new statement. Okay, so now I want to output the total cost. So I'm actually going to call the cost total cost. Okay, so that's the end of our line. Alright, so what is total cost? Well, we need to calculate that. So what I'm going to do is before this line, I'm going to say the total cost is equal to cost per square foot times the area. And now what we're doing is we're going to say that whatever is total cost, which actually I don't have a total cost, I need to declare it, so this is going to be a double. Alright, so I'm declaring my double total cost, and it's equal to the cost per square foot times the area. And now, if you notice, I've declared a block of variables up here, but I'm also declaring this one down here. Now I could move it up here, or I can leave it down here. Either way is okay. So I'm going to go ahead and move it just for sake of keeping everything in the same area. Put it here. So I have a double, which is called total cost, which is the cost per square foot times the area, which the area is already calculated, and the cost per square foot is already calculated. I cannot use these values here unless there is actually a value in area and cost per square foot. If I tried to do this and I didn't actually declare what area is, if I didn't give it an initial value, then this would actually crash the program. All right, so I'm going to save it, and I may or may not get an error, so let's see what happens. So I'm going to go ahead and compile it, and it worked just fine. So the question is, why did it work just fine? And here's why I'm asking that. Area is an integer. Cost per square foot is a double. All right, so what happens is I'm taking a double times an integer. And there is the implicit conversion that occurs that the integer can be converted to a double safely, so the system will automatically do it. Now, if it were something where I was trying to put a double into an integer, then that would cause a problem. So it knows that this is a double, this is an integer, the two of those can get converted and stuck into another double, and that's safe. But if this thing over here were an integer, this wouldn't work, and we would have to cast this thing as an integer. Now remember, to cast it, that's where you put the open parentheses, int, and then close parentheses. So we don't need to cast it because this one's going to work, but if we got an error when we compiled it, then we'd have to go back and do our explicit casting. Alright, so it compiled. I want to run it. And now we get something that looks like this. Alright, so what is this? 2,338.2. You know, that's supposed to be money. And what is this 180? The room of the area of the room is 180 what? If you think back to math class, you have to have your units. So I'm going to change this. The area of the room is however many square feet. And then the cost of the carpet is total cost. But what I want to do is I don't want to display just total cost as some number. I want it to look like money. Alright, so what I could do is I could do something like this, and I could put a dollar sign in front of this. And then when I compile it, and then I run it, I get something that looks like this. Now there's a dollar sign, but I haven't seen money that just has one decimal place. It usually has two. Alright, so I could do some nifty little tricks to make it display two decimal places, or I have an easier way to do it. Instead of displaying total cost, and instead of putting this dollar sign here, I want to take total cost and use a subfunction called toString. And what this will do is it'll take whatever the value is. Remember, this is a double value, and we're going to tell it, instead of a value, convert it to a string. And I want it to format it a certain way. And the way that I want it to format it is going to be whatever's inside of these parentheses. Alright, so if I format it as C, which is currency, what it will do is it'll take whatever this value is, it'll convert it to a string in the currency format, and that's what will actually display out to the screen. So I saved it, compile it, run it, and now I have something that looks like money. Alright, so I want to have a line in between the two of these, and there are a couple of ways I could do that. I could add another console.write line here and just simply not display anything out to the page, or I can use my escape character and use a delimiter for a new line. So what I'm going to do is I'm going to come up here after the sentence for the square feet, and I'm going to put a \n. And now what this will do is it'll tell it, wherever this is, display a new line character. Alright, so I'm going to compile this, run it, and now I have a space between the two of those. So it didn't give me I didn't have to put in an extra line of code. It gave me the extra line because I used the delimiter for a new line here. Alright, I want to modify it a little bit more. I want to ask the user what the value should be. So I'm going to break these back out into two different lines. So I have the integer width is equal to 12 and our length is equal to 15. But I actually don't want it to be equal to 15. I want it to be equal to whatever the user says that it should be equal to. Alright, so what I'm going to do is I'm going to set the length equal to console.readLine. Alright, so what I'm doing is I'm going to ask the user how much, or what is the length. Alright, so I need to actually display something to them to tell them what they are going to actually put in as our value. Okay, so I'm going to do a console.write, and I'm not doing a write line because I don't want it to create a line break. All right, so what I'm going to do is say something like, what is the length? Oops, question mark. All right, and so I can do something like this. So now what it will do is it'll display out to the screen what is the length. And then when it displays this message to me, it will actually put the cursor right beside it, and I can type the length in. All right, so I'm going to put a couple of spaces here before the end of my string, so that way it forces the cursor to be a couple of spaces away from the sentence. I'm going to do the same thing with the width. All right, so I'm going to say console.write what is the width. Oops. Couple spaces, close my statement, and then now I'm going to make the width equal to console.readline. Okay, so what I'm doing is I'm providing a prompt to the user so that way they know what I'm asking them, and I'm giving them a place where they can type the answer. Then the next thing I'm doing is I'm going to take whatever they provide as an answer and stick it into length. Then I'm going to take the width and ask them what the width is, take whatever they type in and stick that into width. Now the problem that I have is whatever I'm reading in on the screen is actually going to be a text value. So I'm going to call this not length, but I'm going to call it that it's a length as a string. Now the catch is the book shows you to do this. They call it length as string and then width as string and so forth. Well, it's going to get really confusing if I have the length as string and then I have the width as string and then I have length and I have width and so forth. What I need to do is I need to start specifying what type of value I have. So what I'm going to do is I'm going to use prefixes, and these are all on Blackboard, and the prefixes will simply designate what the value is. Okay, so in this case it's going to be an integer, so I'm going to put a prefix of int, and I'm going to make my variable name look like this. Okay, so that's an int, but this is coming in as a string, so this actually isn't a string, an int, it's a string, and a string should have a prefix of str. Alright, so then the next one here, this isn't width as an integer, this is a string value, and I'm going to call it str width. And then now what I know is that this width value is a data type of string, which means later on in the program when I use it, then I know that those particular items are strings. And it makes it easier for me to figure out what the data type is for each of these variables. Alright, so I have an integer that's for area, so I'm going to change this to int area. And I have a length, and this is going to be the int length because I have to do the calculation with the integer. And this is going to be int width. Once again, I have to do the calculation with the integer. Alright, and I have this thing here as a double, which a double is dbl as the prefix. So now I can look at this and say, hey, that's a double. Then I have total cost, which is a double, so that's a dbl. And notice I'm making these camel case. I have a cost per square foot, which is a double. And, oh, hey, look at this. I can look at this area now, and I can say, hey, the area is an integer value. And now what that does is, by me looking at this, I can very easily see I'm taking a double times an integer, and the system will automatically cast it as a double. So that's okay, but if it was something that wouldn't automatically cast it, it would make it real easy for me to tell, hey, I need to recast this thing. I need to explicitly cast it. All right, so this is going to be int area. And this is our dbl total cost. So all I'm doing is just simply prefixing all of my variables with what data type it is. And it just simply makes it real easy on me later to be able to figure out what these are. Now there is another naming convention which says that if we use a constant that this value should be all uppercase and then use underscores in between each word. For now I'm going to leave it like this. And then when we start doing things like sales tax, then we'll start using that naming convention also. Alright, so the catch is that I ask the user, what's the length? They type something in for the length. We're going to stick that into a value called strLength. And I somehow need to get this text string into this integer value. So what I'm going to have to do is I'm going to have to explicitly convert these. And so what I'm going to do is I'm going to declare my int length. So I'm going to say int int length, because this is actually where I declare it, is going to be equal to convert dot to int 32. This is the actual conversion. I'm taking whatever is here, converting it to an int 32 value. And what am I converting? I'm converting str length. All right, same thing with our width. So I'm going to declare a new value. It is an integer, so it's an integer data type. I'm going to put int, and then this one is width, is equal to convert dot to int 32, and this time we're going to convert this text string of width. So now what I can look at by looking at this is, all right, we're going to ask the user what's the length. We're going to read in whatever they type and stick it into a string value for length. We're going to ask them for the width. We're going to read whatever they type and put that into a string value for width. Then we're going to take the string value for length, we're going to convert it to an integer and stick it into integer length. We're going to read whatever's in the string width, convert it to an integer, and stick that into int width. Then we're going to take int area and set that equal to whatever these two are multiplied together. We know that the cost per foot is $12.99. We perform our calculation for the total cost, which is a double, which is going to be equal to a double for the cost per square foot times the int area value. The system will do an implicit conversion. It will let us do this. And then we're going to write out to the screen how many square feet they have. We are going to put an extra line. Then we're going to put the cost of the carpet is whatever's in the double value of the total cost to a string as currency. All right, I want to save the program. Then we're going to go ahead and compile it again. Okay, compiles without any errors. Then I want to run it. And now I get something like this. It gives me a prompt. What is the length? The length is 15 feet. Press enter. What is the width? The width is 12. So what it actually just did when I pressed enter at the 15 is it took this 15, it stuck it into str length. That's all that's occurred so far. When I press enter after this 12, it's going to stick it into str width, and then it's going to perform all these other calculations. So I come over here, press enter. So the area of the room is 180 square feet. The cost of the carpet is the same thing, so we're good. We have the right value. But now the difference is that if I type in that it's 20 foot in length and 30 feet in width, now it calculates the square feet and the cost based on the values that I inputted into the system. It's always going to be where whatever I type in is a text string. And I always have to provide an explicit conversion from a text string to a number value if it's something where I want to perform a calculation. All right, so your assignment before class is to reconstruct this program. Make sure you provide comments for every one of these lines that explain what each line does. Make sure you have your console clear, console.readline at the end. And then you're going to zip up your Chapter 2 folder, submit it to Blackboard, and then that's it for the weekend. Have a good weekend. Let me know if you have any questions, and I will see you next week.